Hello and welcome. Thanks for taking the time to join us today. I'm looking forward to our conversation. I'm going to be interviewing you for a lead, potentially staff Android software engineering position. I want to be upfront about my approach here. We're focusing heavily on Android architecture today. Absolutely. Thank you for having me, Mikkel. I'm excited to discuss my approach to architecture and the actual reasoning behind the decisions I make when designing large-scale applications. Excellent. Rather than asking framework-specific questions or API trivia, I'd like to understand how you think about designing scalable systems and leading engineering teams. Feel free to think out loud. If I challenge any of your answers, don't assume you're wrong. I'm simply trying to understand your reasoning and decision-making process. Are you ready? Ready when you are. At this level, I expect my assumptions to be challenged. Reasoning through trade-offs under scrutiny is exactly how good decisions get made in a real production environment. Let's begin with something foundational. Different engineers define software architecture differently. When you hear the term software architecture, what does it mean to you? I ask because many developers say architecture is simply MVVM, the repository pattern, and HILT. What's your opinion on that? That describes a technology stack, not architecture. To me, software architecture is the set of strategic decisions that define how a system is structured, how its components interact, and exactly how it evolves over time while satisfying both functional and non-functional requirements. It's absolutely not about choosing MVVM or MVI. Those patterns, along with tools like HILT, are just implementation choices that help you realize your architectural principles. Real architecture is about defining responsibilities, dependency direction, and creating strong boundaries. Those boundaries are what make the system maintainable, testable, scalable, and adaptable. Right, so you're optimizing for future flexibility. Exactly. A good architecture optimizes for change. Requirements, APIs, teams, and business goals continuously evolve. If your core business logic breaks because you swapped a database library, the architecture failed. That makes sense. Can you give me a practical example of how you evaluate whether an architecture is doing its job in a production environment? Certainly. Suppose the product team decides to replace REST with GraphQL, or maybe we need to add offline support, introduce a new payment provider, or migrate our UI to Jetpack Compose. If those infrastructure changes affect only the relevant layer, while the rest of the application remains completely untouched, then the architecture is doing its job. The entire goal is to isolate change. If adding a feature requires modifying unrelated modules, the architecture needs improvement. Interesting. So, taking a step back, why do we need architecture at all? Architecture solves two types of problems, technical and organizational. Technically, it addresses tight toppling, duplicate logic, massive classes, poor testability, inconsistent state management, and dependency cycles. But organizationally, it's just as crucial. It enables multiple teams to work independently. It simplifies onboarding, supports parallel development, clarifies feature ownership, and allows the product to evolve without slowing overall development velocity. Would you use the same architecture for a startup with 2 developers and an enterprise application with 20 engineers? No. Architecture should evolve with the scale of both the product and the organization. A small team can move quickly with a lightweight architecture. As the engineering team grows to 20 or 50 people, stronger boundaries, strict modularization, and standardized patterns become necessary to avoid gridlock. Let's dive deeper into those standardized patterns. Before selecting MVVM, MVI, or clean architecture for a growing team, what engineering principles would you establish? I'd begin by defining engineering principles rather than technologies. I look for separation of concerns, single responsibility, dependency inversion, unidirectional data flow, immutable UI state, one source of truth, composition over inheritance, explicit dependencies, and consistent error handling. Once those are established, selecting the actual implementation pattern is much easier. Can you elaborate on that first one? How exactly do you define separation of concerns in practice? It means every layer should have exactly one reason to change. The presentation layer changes because the UI changes. The domain layer changes because business rules change. The data layer changes because APIs or storage mechanisms change. If a single class handles rendering, networking, caching, and navigation, it violates this principle. I see. Suppose I challenge that assumption. Why should business logic never live inside a view model? Because a view model's responsibility is orchestration. It should expose immutable UI state, process user actions, coordinate asynchronous work, and emit one-time UI effects. Business logic belongs in the domain layer because it needs to be reusable, testable, and independent of Android. Keeping business rules in view models leads to duplication and tighter coupling with the UI. That's a fair point, but in production, things get messy.
Suppose your view model grows to more than 1,000 lines. What would you do? I wouldn't just chop it into smaller view models to reduce the line count. I'd first audit it to identify misplaced responsibilities. Any complex business validation, like loan eligibility rules or authentication checks, would move down into the domain layer as use cases or domain services. Reusable orchestration gets extracted. What you're left with is a highly streamlined class focused purely on UI state. So you're stripping it down to its core function. Exactly. The goal isn't reducing the line count. It's ensuring every class has a single, well-defined responsibility. That strict boundary prevents the application from degrading into an unmaintainable monolith over time. Let's move down to the data layer. What is the repository pattern, in your view? A repository abstracts where data comes from and exposes a consistent interface to the domain layer. The domain should never know whether the data comes from retrofit, room, a cache, data store, or a mock implementation. The repository makes the decision on how data is retrieved, synchronized, cached, and persisted. So why shouldn't a view model just call retrofit directly? Because that tightly couples the presentation layer to a specific networking library. It ruins testability, duplicates networking logic across multiple screens, mixes concerns, and makes any future infrastructure changes significantly more expensive. Many engineers feel MVVM is sufficient. Why isn't MVVM enough for large-scale applications? And what is the actual difference between MVVM and clean architecture? They solve different problems. MVVM only defines how the UI interacts with presentation logic. It doesn't define business logic placement, dependency direction, module boundaries, or feature ownership. Clean architecture organizes the entire application by defining boundaries and dependency rules. MVVM fits naturally inside clean architecture. Let's talk about those dependency rules. Why is dependency direction important? Dependency should always point inward, toward higher-level business policies. The domain layer should never depend on retrofit, room, compose, hilt, or any Android framework classes. By keeping the arrows pointing inward, business rules remain entirely stable and isolated, even while the outer infrastructure technologies continue evolving and changing. In practice, Compose communicates with the vModel. The vModel invokes use cases. The use cases depend on repository interfaces, and the repository implementations communicate with the data sources. The business core treats the Android framework as just an interchangeable delivery mechanism. That's a highly structural way to look at it. Let's pivot to a staff-level scenario. Imagine you've joined our company. You discover teams are using MVP, MVVM for another product, MVI for a new feature, and MVC across various legacy apps. Leadership wants architectural consistency across the engineering organization, but feature development absolutely cannot stop. How would you approach this? The first thing I wouldn't do is mandate a massive top-down rewrite. Halting feature work to rewrite working code is rarely the right business decision. First, I talk to the engineers to understand exactly why each team made its architectural decisions. Some of those differences might actually be justified by specific product constraints. Once I have that context, I'd work with the leads to establish shared engineering principles. We'd create reference implementations, clear architecture guidelines, and reusable libraries. New features would adopt the new standards while existing features continue operating. High-value modules get migrated incrementally. I'd support teams through design reviews instead of mandates. Finally, I'd measure success using objective telemetry, like build time, defect rate, and delivery velocity. Subjective opinions don't prove architecture works. Metrics do. Absolutely. Resolving architectural debt at scale is about building consensus and proving value, not acting as a technical dictator. Well, that concludes today's Android architecture interview. I really appreciate the depth of your answers. What stood out to me was that you consistently focused on principles and long-term maintainability, rather than simply naming frameworks. That is exactly the level of thinking we expect from our lead and staff engineers.
Do you have any questions for me before we wrap up? Yes, thank you. I do have a few. First, how do architecture decisions typically get made within your engineering organization? Are they driven centrally by a core team, or do individual product teams have autonomy to choose their own patterns? And second, looking beyond just system design, what specific qualities differentiate engineers who are successful in lead or staff roles within your team culture? Great questions. To answer your second point first, the defining quality is leverage. Mastering system design is only half the equation here. Ultimate success at the staff level requires the leadership ability to elevate the entire engineering organization around you. We can dive into exactly how we balance that team autonomy next.